In this short video, I'm just going to give you a rundown of what we're looking for in an example calculations assignment. These are due on the experiment day of each investigation, and they're an individual assignment, which you'll be posting to the Canvas discussion board. So let's consider a hypothetical experiment where we're looking at the density of modern pennies, and both of these documents that I'm showing you are in your examples folder in Google Drive. And if we look at this, they're essentially going to see if the explanation of the different masses of pennies in that measurement activity is reasonable, that the 2.5 gram pennies, the post 82 pennies, are made of zinc. This might be for an assignment where you're supposed to use measure the density of a metal object or something like that. And so the hypothesis in this case is that the 2015 pennies are going to be within 5% of the density of zinc, which is 7.134. They'd be measuring the density, and in this case they're measuring it with two techniques, would be the independent variables. And if they mess up, years of pennies could be different. If the penny's dirty, that could change the apparent density. If there's damage to the penny that adjusts the volume or something, or part of it's corroded, that could potentially do it. So those are things that you might worry about. And here in the confounding variables, they've identified some things they change. There's some stuff on assignment requirements. They've built out a procedure where they're going to start by picking some pennies, measure the mass. Then they're going to measure the diameter and thickness to get the volume. And then a separate way of measuring the volume, they're going to do it by displacement of water. Take some water, add the pennies to it, record the overall volume, and they can, by difference, get the volume of the pennies. So they've done that, and down here in the data table area, there's a data table. And so hopefully your team got to this stage, you have a procedure, you know what data you're planning to collect. That's where you start for these example calculations. And so what I did is I just copied that data table over into a new document. This would eventually go in the Canvas discussion post, keep that in mind. And then all these numbers in the value column are just made up. Okay, you want to try to pick plausible values or reasonable values, but it doesn't really matter. What we're looking for is, do you know what you're going to do with your data and how you're going to perform your calculations? This serves three key purposes. The first is to see if you individually understand it. The second is sometimes when you work on an assignment like this, you realize you've forgotten to collect a key variable or look up a key reference value. And then the last is, if you're really familiar with your calculations as you go through, you can very quickly just run your numbers as you're doing your experiment and see if you're getting good data. So those are a couple reasons why. But just to briefly go over how you estimate these values is maybe from the measurement activity. Remember, the pennies were about 2.5 grams, and so if there's 10 of them, it's going to be about 25. It's on a balance that measures to 3 decimal places, so I just made up some more digits. It doesn't matter. For the diameter of the penny, I think they're probably about 1.5 centimeters, just sort of looking at a ruler and thinking about how big a penny is. That's probably about right, but they're probably not going to all be the same. There'll be some measurement uncertainty, and so I made some higher, some lower, but I have 5 measurements made up again. The thickness, I'm imagining a stack of pennies, and as I imagine it, I'm guessing 1.4 centimeters. Okay, it's not 15 centimeters for a stack of 10 pennies. It's not half a centimeter, just something plausible. And the volume by difference, so they were going to take a graduated cylinder, put some water in the bottom, dump some pennies in, and look at the difference. And making up numbers again, starting with 20 would be enough that all the pennies would go beneath the surface, which is what you need for this method. And then I'm going to guess it's going to go up by just a little over 2 milliliters. That seems plausible. So now I've generated some fake data, and we can run this through the calculations. In each case, I want to get to a percent error, or a density and then a percent error. To get density, I know I need mass and volume. The mass is there directly, but then there's essentially 2 sets of calculations that you do in this example. One would be measuring the volume, one would be by the dimensions, one would be by the mass. So looking here, you'll notice the average diameter was the first step. And just a note, did it with a calculator, so I'm not writing out the whole calculation. 1.494 centimeters. I would need the radius when I go to the area equation, so got that. Calculate the area, calculate the volume from the area and height. Now I have a volume. I can take that 25 grams and get a mass. And the mass is 10.263 in this example. And then when we put it in the percent error problem, this isn't really saying there's 44% error. Okay, if these numbers I made up were true, there would be 44% error. All I've done here is I've walked through all of the calculations on what I'll do with my data once with this hypothetical made up data. And then likewise with the volume of displacement. So the purpose here is to see if you can do the calculations. Don't put significance behind the numbers you get out. Just can you do all the calculations? And then I would essentially copy and paste this into a discussion post. Now I typed this out. It's not perfect. You could also write it out on paper and then like take a picture of it and put it in as an embedded image in your Canvas post. There's a couple options. So this was a hypothetical experiment, not connected to what you're doing, but it will give you an idea of what you would be looking to do in these calculations. Again, the numbers you start with are the actual measurements you would expect to make in the lab. Just make up numbers for them. Don't say, oh, I need a density and make up a density. Start with the measurements you would make to get that. And then run through all the calculations that you would do if those were your real data. And there you go. So if someone is able to complete this assignment, then I, as an instructor, have confidence that they'll be able to do their data analysis later. Okay, good luck.